Hello again. In the previous video, we finished quadratic equations, complex numbers, and even quadratic applications. Now we're moving into something called polynomial functions. Polynomials include things like linear functions, quadratic functions, cubic, um, quartic function, even higher degree functions. So let's begin with the quick rules. A polynomial is a sum of terms ax to the power of n, where n is a non-negative integer. Degree is the highest exponent with a non-zero coefficient. The leading coefficient is the coefficient of the highest degree term. And n behavior is controlled by degree and leading coefficient. Okay, those might not mean anything to you now, but they will after this lesson. Okay, so example number one, for f of x equals negative 2x to the fifth plus 3x cubed minus 7x plus 4, state the degree, leading coefficient, constant term, and in behavior. All right, so we're going to do all of those things. The degree is the highest exponent, okay? So the highest power of x is 5, okay? That's the highest power. This has a power of 3, this has a power of 1, and then this has no power, okay? So power of 1, power of 3, power of 5. So the degree is 5. The leading term is the term with the highest degree. So the leading term in this case, leading term is going to give me negative 2. So the leading term is the leading coefficient of this term, right? So we have state the degree, leading coefficient. Leading coefficient would be negative 2 in this context. Okay, so the constant term is the term with no x. Okay, so the leading term, and this is the leading coefficient. Okay, constant term. Constant term is the term with no x, which would be 4. Okay, so that is the constant term. Now, determine the end behavior. So this is an odd degree polynomial. What I mean by odd is notice the power of 5. Okay, so this is an odd degree polynomial with a negative leading coefficient. So odd degree numbers or odd degree means the ends go in opposite direction. Okay, so negative leading coefficients means the right goes down and the left goes up. Okay, so for example, as x tends to negative infinity, the function of x is going to go to positive infinity. As x tends to positive infinity, the function of x tends to negative infinity. Okay, so in words, the graph rises to the left, right? Rises to the left and falls to the right. So rises left, falls to the right. Okay, let's continue. Example number 2. Decide whether each expression is a polynomial. Explain any restrictions. We have x squared cubed minus x plus 9. We have 3 over x plus 2, square root of x plus 1, x to the fourth minus 5x squared. All right, let's deal with part A first. So part A, we have 4x cubed minus x plus 9. So this is a polynomial, and all exponents are non-negative, right? So this is essentially 1. So all exponents are non-negative. So this is a polynomial. Let's look at B. So we have 3 divided by x plus 2, right? 3 divided by x plus 2. Now this has a power of 1. So if we were to simplify this, this is actually written as 3. All right, so I'm going to rewrite this because remember, this has a power of 1. Okay, so anytime you see a number and a variable, if you remember the exponent rules, this is essentially this can essentially be moved up and be made a negative. So this is x to the power of -1 plus 2. Okay, so the exponent -1 obviously clearly is negative. So a polynomial cannot have a negative exponent on the variable. That's that's a no-go. So polynomial, no. The reason is negative exponent. Okay. Okay. Part C. Part C is the square root of x plus 1. Okay, so square root of x plus 1, very important. This is actually x 1/2 plus 1. Okay, because remember, this is essentially like you have x to the power of 2 with a 1 on the outside. So when we simplify, it becomes half. So is this a polynomial? A polynomial cannot have a fractional exponent on the variable either. So this is not a polynomial. And the reason is no fractional exponent. Okay, can't have that. Okay, part D. So we have x to the power of 4 minus 5x squared. Okay, might have already guessed it. This is definitely a polynomial. It has a power of 4 and a power of 2. Works out perfectly. They're both non-negative numbers. All right, solve or pause and try the last one. Okay, so the highest power of x is 4. So this has a degree. I'm going to abbreviate degree. A degree of 4. Okay. The leading term, I'm going to use that as LT. The leading term is 6x to the power of 4, or x to the fourth power. The coefficient is 6. Okay. Coefficient of the leading term is 6. And so this is an even degree polynomial with a positive leading coefficient. So even degrees, when it has even degrees, like 4, with a positive leading coefficient, it means it opens up in the same direction. So positive leading coefficients means that both ends go up. So as x tends to negative infinity, px in this case is going to tend to positive infinity. As x tends to positive infinity, px is going to also tend to positive infinity. So the end behavior is left is going up and the right is going up. Well. Right? Example number 3. For f of x equals x plus 2 squared, parentheses, x minus 1, parentheses, x minus 4. It says list the zeros, multiplicities, and whether the graph crosses or touches 0. Okay. And you already know how to do these. Some of the languages is I'm going to explain. So first of all, we want to write x plus 2 squared. And we want to set the factor equal to 0. Okay. So we're going to set this factor equal to 0, which is going to be x plus 2 equals 0, subtract 2, subtract 2, x is -2. Okay. So the exponent is 2. So the multiplicity is 2. Okay, because of the exponent. So even multiplicity means the graph touches the x-axis and turns around. Okay. So so 0, x is equal to negative 2. Multiplicity, 2. And the behavior is it touches. Now, next we need to factor. Okay. So we have x minus 1 here. So we need to set it equal to 0 as well. Okay. So x minus 1, 0, and x is equal. Okay. Now, there is no visible exponent for this one. Right? So the multiplicity is 1. Odd multiplicities mean the graph crosses the x-axis. So 0, we have x equals 1. We have a multiplicity of 1. Then we have the behavior crosses. Right? Remember the lingo. Okay. And then the last factor, we have x minus 4 cubed. So we have to set it equal to 0. X minus 4, 0. At 4, x is equal to 4. Okay. So we have the multiplicity. The multiplicity is 3 because it has a power of 3 here. And it's an odd multiplicity, which means the graph crosses the x-axis. Because the multiplicity is greater than 1, the crossing may flatten the x-axis. So we know what the 0 is. The 0 is x is equal to 4. Multiplicity said was 3 because of the power of 3. And the behavior is cross with flattening. Okay. So the final answer is x equals negative 2, the multiplicity of 2, it touches. X is 1, or the 0 is 1, multiplicity is 1, it crosses. X is equal to 4, multiplicity of 3, crosses with flattening. Now, example number 4, write a least degree polynomial with zeros, negative 3, 2, 5, where x is equal to 2, has a multiplicity of 2, using leading coefficient. Okay, so a 0 gives a factor. If x is equal to negative 3 is a 0, then x plus 3 is a factor. If x is equal to 2 is a 0, then x minus 2 is a factor. Notice I'm shifting it, and I'm also shifting it there. Okay. Since x is equal to 2 has a multiplicity of 2, we use the factor twice. So if x is equal to 5, what we see here, then x minus 5 is a factor. Okay. So we're going to write f of x equals x plus 3, x minus 2 squared, and x minus 5. So this is already a least degree polynomial with a leading coefficient of 1. And so we can leave it in factored form. If we expand this, it'll become f of x is x to the 4th minus 6x minus 3x squared plus 52x minus 60. This is if expanded. We computed this, we would end up with this. So the factored form is usually more useful because it clearly shows what the zeros are. It clearly shows what the multiplicities are. Okay. Let's get a common mistake. Common mistake is this. A student says that 7x cubed minus 4x squared plus x minus 9 has a degree of 4 because it has 4 terms. What is their mistake? So the degree is not the number of terms. The degree is the highest exponent. The degree being the highest exponent, excuse me, the degree is not the number of terms, it's the highest exponent of x. And so this expression has 4 terms. This is 1 term, terms, 3 terms, 4 terms. You have 7x cubed, negative 4x squared, positive x, negative 9. So the highest exponent is 3. So what is that? That is the degree. So the correct degree is 3, not 4. Okay. One line. Okay. I know this was a lot, but let's go back to the quick rules to review. So polynomial terms are written in ax the power of n, where n cannot be negative. We looked at negative, we looked at fractional, and we also looked at positive. The degree of these terms is the highest exponent, and the leading coefficient the coefficient or the leading coefficient is attached to the term that has the highest exponent. A constant term is the term that has no variable attached, and the end behavior depends on what type of degree it is, the leading coefficient. And just for the record, um, even you have an even multiplicity versus an odd multiplicity, the graph touches. Okay. If you have an odd multiplicity, then the graph is going to cross. Okay. So do not confuse the number of terms also with the degree. The degree comes from the highest exponent. Okay. And that concludes this video. Thank you.